Amplify Science, Matter and Energy in Ecosystems, Unit Chapter 3, Lesson 3.3, Looking for the Missing Carbon Review Video. So in step 1 in the warm-up, you're asked to select which claim. I'm going to go ahead and point you towards claim 2 right now. We do know that at this point total carbon stays the same. It's not getting into or out of the biodome. It's contained inside. And so we know that that's a closed system and that the total amount of carbon is going to stay the same. It would move between abiotic, like the air, and then the organisms, the producers, consumers, decomposers. It's going to move back and forth between those two types, but it's still going to be the same total amount overall. In the simulation, which one of the options you think is that you're going to predict? I'm going to point you in the right direction. Carbon is now in the dead matter of the ecosystem. Okay? At this point, you've tested the lack of decomposers. You've reduced the decomposers enough times to know that when you do that, the dead matter, energy storage molecules, builds up in the soil. It's not released as carbon dioxide back into the abiotic air, and it doesn't make it available for the producers to make energy storage molecules to be passed on to the consumers. So if we open up the simulator and we run it, they say run it for 20 time units. I'm going to speed this up to 4 times over just to save us a little bit of time, and there it is, about 20. Then it says kill all the decomposers. Kill them as fast as I can. So I'm taking them out. No more decomposers. Okay, they're there. They're all gone. And then it says run it for another 100 time units. So it runs and runs and runs and runs. Notice that since there's no decomposers, no energy storage molecules are being transferred to those decomposers. All energy storage molecules are being stored in the dead matter in the bottom. None of that is being converted to CO2 and traveling back up into the atmosphere as abiotic CO2 to be used by producers. So we can see that the overall level, even though it's going around and around and around in the producers, consumers, decomposers in the air, energy storage molecules are building up more and more and more in the dead matter, and that's eventually going to be a problem. So we head back here and we load a snapshot of what's going on. So grab a screenshot, upload it. Was your prediction correct? In this case, mine was. Okay, lack of decomposers would lead to a buildup of energy storage molecules in the dead matter of the soil. We move on to screen 2, and it just reinforces that. Since carbon cannot be produced or used up, the total amount of carbon in a closed ecosystem does not change. Okay, it can't get in, it can't get out. But the amount of carbon increases in the abiotic, for example, the air or the soil, then it also decreases in biotic matter. And if the amount of, and then in the amount of carbon decreases in abiotic, then it has to increase in biotic. Regardless of what just came out of my mouth, what I'm saying is if it goes up in one, it has to go down in the other. And if it goes down in one, it has to go up in the other. Reading. You're going to open up 2 of the files, file 2 and 3 according to the instructions. You should look at others, but I have 2 and 3 open, looking directly for the notes from Dr. Corey. And he says, why didn't they include an ecologist in the team? Ecologists understand how ecosystems work. So you're looking for these sticky notes. Okay? So of all the scientists, there's a lot of experts, but none of them are going to study probably the whole cyclical nature of carbon and recognize that one thing might affect another. By the way, you might note in here too that in their scenario, where is it? Sarah Willard, 29-year-old goat farmer from Wenatchee, Washington, so local. If you hop into the second article, Biodome File 3, it says, I wonder why they decided not to include worms. Bacteria need worms to break down. So there are some decomposers that they crossed off the list. They did not include. And it's a good thing that they included producers for both land and water ecosystems. That's great, but right now, things are pointing to lack of decomposers. We only have bacteria and fungus, but nothing else that would break things down. So we also learned, in file 2 at the bottom, that they're burying dead matter. Matter of fact, they're not only burying it, it says up here that they're putting it in plastic bags. Decomposers can't get through plastic, or if they do, it would take quite a long time. So all that material is trapped in the soil. Think about this simulation. Okay, we go back to the simulation and look. No decomposers, all this dead matter building up in the soil. Imagine that they're little bags of material that they buried in the biodome. It's going to create a problem. So we can explain that in the two boxes below. We found those sticky notes that describe there's no ecologist and there are less decomposers, and that's going to create that problem. In the homework step, you are opening up the sorting tool, and I have that open, and they want to know what's happening in these two locations in the ecosystem. Now, we do know at this point that total carbon in ecosystems stays the same. It's a closed ecosystem. It can't get in, it can't get out, so it's always going to stay the same. Abiotic carbon decreased, carbon in living things decreased. Remember, a total system, if things are going down somewhere else, they have to go up in another area, which tells us clearly that that has to increase quite a bit. If it dropped in these areas, it has to increase here. Besides, we also can explain that from information we got from the files and the simulation, that it's building up in the dead matter and not being released again into the cycle as carbon dioxide. So that gives you enough information. So you grab a screenshot of that and explain what I just told you about it building up in the dead matter and not being cycled back through, and that affecting the whole biodome and causing a decrease in, over time, carbon dioxide, which decreases producers and consumers. And hand that in. At that point, you've got a really good idea of what's going on.